What if Europe has lived many lives before us? Worlds so alien that no city, empire, or civilization could survive them. Beneath the continent we recognize today lies a history 500 million years long, where oceans drowned the land, ice erased mountains, and entire ecosystems rose and vanished long before humans ever existed. What we call Europe is only the thinnest surface layer of a far deeper, forgotten story. Here are worlds that vanished long before our species existed. Seas patrolled by armored leviathans, forests humming with dragonflies the size of seabirds, islands where giant pterosaurs stalked dwarf dinosaurs. Europe's foundations were laid by oceans that came and went, volcanoes that choked the sky, and ice sheets that ground mountains to dust and then withdrew. In the journey ahead, we walk backward through deep time, meeting the architects of Europe's hidden history. Their anatomies and survival strategies still echo in the animals that share our world today, and in some respects, in us. This is their story, and in ways we are only beginning to grasp, it is ours as well. Long before Europe had familiar coastlines, it lay beneath warm, shallow seas. 500 million years ago, in the Cambrian, the seafloor that would one day underlie parts of Europe teemed with creatures that seem almost mechanical to modern eyes. Imagine a dim, bluish light filtering down through clear water. Trilobites scuttle over the mud like miniature tanks, their segmented bodies protected by hard exoskeletons and compound eyes made of calcite lenses. Many species can roll into tight defensive balls, their spines locking together, while others bristle with elaborate horns or carry broad head shields whose purposes, display, defense, or hydrodynamics, are still debated. In the water above, predators like Anomalocaris glide with unsettling grace. Nearly a meter long, it swims by rippling lateral lobes along its body, steering with a flexible tail. At its front, two barbed appendages reach forward, snapping shut around prey and drawing it toward a circular mouth lined with hard plates. When it seizes a trilobite, the crunch of shell would have been both sound and sensation in this early arms race. Armor versus jaw, defense versus hunger. By the Devonian, jawed fishes had transformed these seas. Placoderms, armored fish with bony plates wrapping head and shoulders, became apex predators. Giants like Dunkleosteus reached several meters in length, wielding bone blades instead of teeth. Biomechanical studies suggest their bite forces rival or exceed those of modern large crocodiles, easily crushing shells and bone, while rapid jaw opening created suction that pulled prey inward before the crushing blow. In the shallows, early tetrapods, still mostly fish in shape, began testing the boundary between water and land. They bore limb-like fins with bones corresponding to humerus, radius, and ulna, and skulls that could lift above the surface to breathe air through nostrils. Hauling themselves onto mudflats to bask or escape aquatic predators, they traced the first uncertain vertebrate paths onto a continent that would one day be called Europe. The strategies forged here are still recognizable. Crushing jaws reappear in modern sharks and alligators. Compound eyes echo in horseshoe crabs and mantis shrimp. These Cambrian and Devonian seas were not primitive rehearsals, but fully functional ecosystems, run by the same evolutionary logic that governs life today. Jump forward 100 million years. Europe lies near the equator, fused into the supercontinent Pangaea and draped in vast carboniferous swamp forests. Towering club mosses, horsetails, and early seed plants create a green, humid twilight over waterlogged ground. Their trunks rising like pillars from black, peaty soil. The air itself is different. Atmospheric oxygen peaks around 30+%, far richer than today. And this supercharged atmosphere allows arthropods to grow to sizes that feel impossible by modern standards. In the canopy, Meganeura, a dragonfly relative with a wingspan approaching 70 centimeters, patrols with astonishing precision. its huge compound eyes tracking motion across a wide field, its veined wings beating with a dry, crackling buzz. When it spots prey, a smaller, it accelerates in a straight, unwavering line. Spiny legs snap shut around the victim, and Meganeura lands to feed, its mandibles shearing through chitin with mechanical efficiency. To anything its size or smaller, the shadow of those wings means the hunt is already over. On the forest floor, Arthropleura, a millipede-like arthropod over 2 meters long, undulates through leaf litter. Its armored plates gleam damply with condensation as hundreds of legs move in rippling waves. It likely fed on decaying plant matter and fungi, turning the forest's endless rain of leaves into its own massive bulk and into soil. In streams and pools, labyrinthodont amphibians, thick-bodied predators with broad, flat skulls, wait like submerged logs. Their intricately folded maze-toothed dentition strengthens their bite as they ambush fish and other prey with explosive lunges. Mouths snapping open so fast, they generate suction that helps drag victims in. These forests would one day become Europe's coal seams, powering the Industrial Revolution, a deep-time link between ancient swamps and modern industry. Yet the same oxygen that allowed giant insects also made the world burn easily. Wildfires, sparked by lightning, could race through the canopy, forcing creatures to flee into water or die, leaving behind charcoal layers that still mark their passage. The Carboniferous shows how environment shapes possibility. High oxygen lets arthropods test the limits of exoskeletons. Waterlogged lowlands favor ambush predators and amphibious lifestyles. What seems like a hard rule today, for example, the maximum size of insects, turns out to be a product of conditions, not a fixed law. As climates dried and Pangaea's interiors became more seasonal, Europe's coal swamps shrank. In their place, Permian plains and woodlands favored new kinds of land vertebrates. Among the dominant forms were synapsids, distant relatives of mammals, already experimenting with features that point toward our lineage. Dimetrodon, often mistaken for a dinosaur, was a sailback predator more closely related to mammals than to reptiles. Its tall, vascularized sail likely helped regulate body temperature, absorbing morning sun and bleeding off midday heat. While its differentiated teeth, incisors, canines, and slicing posteriors show an early move toward the complex dentitions that would later define mammals. Herbivorous therapsids with barrel chests and reinforced skulls roamed in herds, cropping low vegetation with blunt teeth. Some forms may have used their thickened heads in bouts of headbutting, while others experimented with more upright limb postures, lifting their bodies off the ground and improving endurance on land. Saber-toothed gorgonopsids stalked them with elongated canines built for killing bites, relying on stealth and short bursts of speed. Then came the Great Crisis. Around 252 million years ago, massive eruptions in Siberia released vast quantities of greenhouse gases, driving rapid warming, ocean acidification, and deep-sea anoxia. The end Permian extinction eliminated an estimated 90% of marine species and a majority of land vertebrates, dwarfing even the later dinosaur-killing event. European rocks record this collapse in thinning faunas, simplified plant communities, and vanished reef systems. Ecosystems unraveled as plants died, herbivores starved, and predators lost prey. When the worst passed, survival favored small, generalist, stress-tolerant species. Early archosaurs and modest synapsids among them, lineages that would later produce crocodiles, dinosaurs, birds, and mammals. The Permian's message is stark. Even long, stable ecosystems can fail when pushed past key thresholds. Runaway greenhouse effects and disrupted ocean chemistry are not just ancient curiosities. They are warnings carved into stone about what happens when planetary systems are driven too far, too fast. With the Mesozoic came a new Europe. an archipelago scattered across warm, shallow seas. Isolation on islands, limited resources, and changing sea levels produced some of the strangest dinosaurs and reptiles ever known. Early in this era, large herbivores like Plateosaurus browsed on conifers and ferns across regions that include modern Germany, walking on 2 or 4 legs as needed, while agile carnivores such as Liliensternus hunted them through floodplains and river valleys. But as Jurassic and Cretaceous seas further fragmented Europe, evolution on islands took dramatic, sometimes counterintuitive turns. On what is now Romania's Haiteg Basin, once an island, sauropods evolved dwarf forms. Magurosaurus, a titanosaur, shrank to roughly horse size, yet kept the long neck and tail of its giant cousins, an adaptation to limited island resources and perhaps reduced predation. It moved in small groups through patchy forests, cropping ferns and cycads. At the same time, one of the largest pterosaurs known, Hatzegopteryx, dominated the skies and likely the ground. With a wingspan around 10 meters and a massive, robust skull, it probably hunted on land as much as in the air, stalking smaller dinosaurs, juvenile sauropods, and other vertebrates. Standing on all fours, it would have towered over most of its potential prey, its long neck and spear-like beak turning the forest edge into an ambush corridor. Across other European islands, herbivores like Iguanodon grazed in herds, using beaks to crop plants and thumb spikes for defense, while fish-eating theropods such as Baryonyx waded in rivers. With their crocodile-like snouts and hooked claws, these hunters converged on the same solution modern herons and crocodilians used to catch slippery prey: long jaws, sensitive snouts, and a rapid snap. Offshore, mosasaurs, marine lizards turned sea predators, and plesiosaurs ruled the water column. Mosasaurs propelled themselves with powerful tails and flippers, their jaws lined with backward curving teeth that trapped struggling prey. Plesiosaurs combined fore-flippers for maneuvering and, in some species, elongated necks for rapid strikes into schools of fish or cephalopods. Mesozoic Europe demonstrates evolution's improvisational flair under constraint. Island dwarfism and gigantism created ecosystems where horse-sized sauropods grazed beneath aircraft-sized pterosaurs, and familiar ecological roles: herd herbivore, stalking predator, aerial hunter, were filled by anatomies very different from anything alive today. 66 million years ago, a 10-kilometer asteroid struck near modern Mexico, triggering firestorms, global darkness, and the extinction of non-avian dinosaurs, pterosaurs, and many marine reptiles. With those dominant groups gone, Europe's landscapes reset. In the Paleogene, forests spread across a warming continent, and mammals expanded into roles they had long been kept from. Small, nocturnal forms diversified into carnivores, grazers, browsers, climbers, diggers, and omnivores of surprising shapes and sizes. Among the more imposing European mammals of the Miocene was Deinotherium, a relative of elephants with downward curving tusks rooted in the lower jaw. Standing roughly 4 meters at the shoulder, it reshaped woodlands by knocking down trees and opening clearings. Its strange tusks perhaps used to strip bark, hook branches, or dig for roots. Its calls, low, infrasonic rumbles, could have rolled through forests as announcements of its presence. Entelodonts, sometimes nicknamed hell pigs, though they were not true pigs, roamed as powerful omnivores with massive jaws suited to cracking bone and tough plant material alike. Robust skulls with heavy muscle attachments hint at crushing bites, and healed injuries on fossils suggest frequent, violent confrontations with rivals. Calicotheres, long-limbed browsers with large claws that walked on their knuckles, looked like no modern animal, yet filled the niche of high-reaching leaf eaters. They used their claws to pull down branches, combining ungulate bodies with ape-like forelimbs in a unique solution to feeding on tall vegetation. Slow but imposing, they relied on size and armament rather than speed. As climates cooled and dried into the Miocene, forests gave way in many areas to more open habitats. Early horses in Europe evolved from small, multi-toed forest dwellers into taller, fleet-footed grazers with single, hoofed digits. Ruminants refined their stomachs and teeth for processing abrasive grasses, turning sunlight and silica-rich plants into muscle and horn. Predators followed suit. Cat-like nimrovids and early true cats evolved powerful limbs and specialized killing canines, some developing saber teeth for precision throat or belly strikes. Rather than outrun prey, these ambush hunters relied on stealth and explosive power, trading stamina for speed and accuracy. Fossil sites such as Messel in Germany, with exquisitely preserved Eocene mammals, reveal this burst of experimentation in microscopic detail for outlines, stomach contents, even last meals. The diversity of body plans, from tiny gliding insectivores to bizarre knuckle-walking browsers, shows that mammal evolution is not a simple march toward familiar modern forms, but a branching tree full of dead ends and successes. Two million years ago, Europe entered the climatic rhythm of the Pleistocene. Alternating glacial and interglacial periods driven by shifts in Earth's orbit and tilt. During glacial maxima, vast ice sheets advanced over northern Europe, grinding rock, carving valleys, and pushing ecosystems southward. South of the ice lay the Mammoth Steppe, open, windswept grasslands stretching across Eurasia. Woolly mammoths, with shaggy coats and sweeping tusks, were among the giants that thrived on these steppes. Standing around 4 meters tall and weighing several tons, they used their tusks to sweep aside snow, break ice, strip bark, and perhaps for social displays and combat. Their herds transformed vegetation and soils, turning frozen plains into dynamic, grazed landscapes. In warmer intervals, straight-tusked elephants, even larger than mammoths, moved through temperate forests. Cave bears, some of the largest bears ever known, crowded into European caves to hibernate, leaving behind vast accumulations of bones that testify to dense populations and intense competition for winter shelters. Megaloceros, often called the Irish elk, carried antlers spanning more than 3 meters. These enormous racks, costly to grow and cumbersome in dense woods, served as extravagant advertisements of male fitness during the rut. When stags clashed with weapon against weapon, the crack of bone on bone echoing across river valleys. Predators matched the herbivores in scale and power. Cave lions, slightly larger than modern African lions and often reconstructed without manes, hunted in groups and tackled large prey. Packs of robust wolves and perhaps late-surviving saber-tooths, such as Homotherium, exploited herds with a mixture of endurance, cooperation, and ambush. During the later Pleistocene, humans entered this stage. Neanderthals, cold-adapted and powerfully built, hunted large game and used fire, tools, and shelters to survive in glacial Europe. Modern Homo sapiens arrived later, bringing more complex tools, tailored clothing, long-range weapons, and intricate social networks that increased hunting efficiency and resilience. As the last ice age ended and forests reclaimed much of the Mammoth Steppe, many of these megafauna disappeared within a few thousand years, a blink in geological terms. Rapid climatic shifts, shrinking habitats, and human hunting pressure likely interacted to drive mammoths, megaloceros, cave bears, and cave lions to extinction across most of Europe. The emptying of this megafaunal stage left Europe to a new dominant ecosystem engineer, a highly social primate capable of agriculture, cities, industry, and planetary scale impacts. Across 500 million years, Europe has been remade again and again, by oceans and ice, by extinctions and rebirths, from trilobite seas to carboniferous forests, dinosaur islands, and mammoth-haunted ice fields. The same laws of climate, evolution, and chance that shaped those vanished worlds are still running now, with our species suddenly at the center of the story. If you want to keep traveling through deep time like this, subscribe so you don't miss the next chapter in Earth's hidden history. And drop a comment below if you could safely visit just one of these ancient Europes: the primordial seas, the giant insect forests, the dinosaur islands, or the Ice Age plains. Which would you choose and why?